Hi everybody. Today we are going to be working on 13.2.3 parallel and perpendicular lines. I need to get my little iPad set up going here and then we can get started. All right. So definition first of parallel lines. That's where we're going to put in that first blank is parallel lines. So we've got parallel lines that are going to be two or more lines that never intersect and that they have the same exact slope. So same slope. So that just means if we've got two lines and we have the same exact slope, they are never ever going to intersect. Even if we've got one like way over here, as long as it's got the same slope, they're not going to intersect. Oftentimes you see little arrow kind of marks put on those lines to indicate that those lines are parallel. The next definition we're going to fill in is perpendicular. So perpendicular lines are two or more lines that intersect at a 90-degree angle. And their slopes are going to be opposite reciprocals of one another. So opposite just meaning if one is positive, the other one's going to be negative. And then a reciprocal is going to be like if you multiply two reciprocals together, the product of those reciprocals are going to be equal to 1. Another way to say that a reciprocal is that you just flip-flop the numerator and the denominator. So for example, if I've got 2/3, then the reciprocal of 2/3 is going to be 3/2. And so they just flip-flop. The other things we're going to fill in here is that the product of the two slopes, so the product of regular reciprocals is 1. The product of the two slopes of perpendicular lines would be -1 because one's going to be 2/3 and the other one would be -2/3. So I'm going to put that in there so that you don't look at that later and wonder why is one positive and one is negative. Because my original example in here was just giving you a reciprocal, but I happened to put it right below perpendicular lines, so I don't want that to mess you up. So another example I'd like you to look at is maybe something like the number 5 and think about what would be the opposite reciprocal of that. And so think about how that would be like 5/1. And so the opposite reciprocal, so it'd be negative, because if, the 5 was positive, so it'll be negative, and then it's going to be 1/5. How about if we had like 4/7, so -4/7, and you want the opposite reciprocal. So that means it's going to be positive, and then it'll be 7/4. And so these two slopes, like -4/7 and 7/4, would be slopes that could represent the slopes of two perpendicular lines, or lines that are perpendicular to one another. All right, so for example, it says give the equation of a line that is parallel to the line y equals -3x + 4. So give any equation of a line that is parallel to y equals -3x + 4. Well, what do we know about, parallel lines? Parallel lines means that they're going to have the same slope. And so what that means is that we can write y equals -3x + 2 would work. We could write y equals -3x because, right, the slopes are the exact same. What we're changing is this piece right here where it's intersecting our y axis. And so here our y-intercept will be at +2. Here, when there's nothing there, it's going to intersect right at the origin, right at 0, 0. So really it could be y equals -3x + c, which is c is any constant as long as c cannot equal 4. Because we don't, if I said it equaled 4, that would be the same exact line. So they'd be coinciding lines rather than just parallel lines. So you can't do c equals 4. For our next example, it says determine whether the lines 2x plus 3y equals 5 and y equals negative 2/3 x minus 4 are parallel, perpendicular, or neither, and explain your reasoning. So if I was you, I'd pause the video and see if you can honestly figure out these next few examples on your own, and then restart the video and see how you did on your examples. So what we're going to do when we're trying to figure out whether lines are parallel, perpendicular, or neither, we need to put them in the same form so we can see their slopes. So that's what I'm going to do with this one. This one's already in y equals mx plus b form, so in our slope-intercept form, and I'm going to be comparing their slopes. So I'm just going to put a number 2 up here and a 1. So equation 2, my slope is negative 2/3. All right, so let's see what the other one is. So it's going to be 3y equals negative 2x plus 5, because I just moved the 2x over like that. And then we're going to divide everything by 3. So then I'm going to get y equals negative 2/3 x plus 5/3. So what I see here is that the slopes are the same and my y-intercepts are different, which means that my those two lines are going to be parallel. So lines will be parallel because same slopes and different y-intercepts. All right, next one. Find the slope of a line that is perpendicular to the line y equals 2x minus 6. So we need to figure out, well, what's the slope? The slope of this line is 2. The slope of the line that's going to be perpendicular to that one. So here's your little symbol for perpendicular. So my perpendicular slope is going to be negative 1/2. So I can plug in anything I want for my y-intercept. So I could even do y equals negative 1/2 x, and I could even do minus 6. So that means that those two lines are both going to cross at, down here at negative 6, 4, 5, 6. They're both going to cross here. And one is going to have a positive slope of 2, so it's going to be up 2, right 1, up 2, right 1, and then the other one's going to have a down 1, right 2 slope. So it'd be kind of like this, and then my other one would look like that. And so that would be kind of what those two lines look like. And then they would form right angles with one another because they're perpendicular lines. So really you could put in here y equals negative 1/2 x plus c. So c, the constant back here, could be anything. You could even say y equals negative 1/2 x, where it intersects at the origin, like here. And so this would be about that. This would be that line, about like that. So it's just obviously a rough sketch, but it'd look kind of like that. All right, so which of the following lines are perpendicular to the line negative 14x plus 2y equals 3? I can't stop yawning today. Sorry, guys. So 2y equals 14x plus 3. And I'm going to divide everything by 2 so I can figure out what my slope is. So y equals 7x plus 3/2 is going to be my equation of my line. And again, I'm looking for the line or lines that are perpendicular to this one, which means the slope that I'm looking for is going to be negative 1/7, right? So that'll be the perpendicular slope I'm looking for. So I'm just gonna kind of go through each of these and put them in slope-intercept form. So here I would have 7y equals negative x plus 0. Then I would divide by 7. And so this first one would be y equals negative 1/7 x plus 0, or just negative 1/7 x. So that one will work. Let's check the other ones. This next one is going to be y equals 7x plus 2. That won't work. That one would be parallel. Letter C is going to be negative 7y equals negative x plus 5. we would divide everything by -7. And so this one would be y equals 1/7 x minus 5/7. So that one won't work either because this is positive instead of negative right there. And then for this last one, I'm kind of running out of space here. I'm going to say 2y equals 14x minus 1/3. And you can probably already tell that as we are dividing that, it is not going to be -1/7. It's going to be 7x. And then you would multiply that, like multiply by the reciprocal for your y-intercept, and it's going to be -1/6 for that. But that slope isn't the opposite reciprocal either. So the only answer that we're going to get is letter A for that one. Number 5, it says, write the equation of the line that is parallel to this line, and it goes through the point right here of -2,4. So what you're going to need to do, we're going to follow the steps that we did on the previous lesson where we had those 4 scenarios where we were given particular pieces of information and you had to write the equation of a line. We're going to do the same thing here in this lesson, but this time we've also got to include the fact about what we know about parallel and perpendicular lines. So right here it says, write the equation of a line that is parallel to this one. And it goes, and our line, the one that we're looking for, is going to go through this point right here. So this is going to be the scenario, I think it was scenario 2, where they're going to give you the slope and then they give you a point. This one's going to be most similar to that scenario because we're going to find the slope from this equation right here. So I'm going to go ahead and put that in slope intercept form. And I'm going to have, I'll just say -y equals -x plus 5. And now I'm going to divide everything by a -1. And so then I'm going to get y equals x, because negative over a negative is a positive. And then a positive over a negative is going to be a negative. We're going to get this for our equation. So the slope of the line that I'm looking for is parallel to this one. Well, what's the slope here? It's 1. So my parallel slope of the line that I'm looking for is also going to be 1. And so now I'm also given that it goes through this point. So here I am, I've been given an x and a y, and then I've been given the slope. So remember from the previous lesson, we're going to plug that information in here. So here I've got 4 equals 1 times -2 plus b. And then I've got 4 equals -2 plus b. Add the 2 over, and then 6 is equal to b. So then your final answer for your equation is going to be y equals -x, or I'm sorry, not -x, positive x. Get rid of that. I was looking at the negative on the 2, but here's my slope right there. So it's gonna be 1x, which we don't need to write 1. We can just write x plus 6. And that's going to be the equation of the line I'm looking for. And it's parallel to this one. All right, so now number 6, it says, write the equation of a line that contains the point here. So that gives me an x and a y, and is perpendicular to the line, y equals 2x minus 6. So the slope of this line is 2. The perpendicular slope is going to be -1/2, right? Then the opposite reciprocal. And then it's going to go through the point of 1,5. So again, we're going to plug in the information into our slope intercept form. So I'm going to plug 5 in for y, my -1/2 in for m, the 1 in for my x plus b. So -1/2 times 1 is just going to give me -1/2, right? So we're going to get 5 equals -1/2 plus b. Then we're going to add that 1/2 over. And we're going to get 5 and 1/2 equals b for my y-intercept. So then my final equation is going to be y equals -1/2 x plus 5 and 1/2. And that's going to be my final answer for that one. So let's look at number 7. Number 7, it says, which of the following is the equation of the line that is parallel to this? And it goes through the point -3, 1. So which of the following is the equation of the line that is parallel to that one, which means our parallel slope is going to be -2, and then it's going to go through the point 1, -3. All right, so here's a couple options. One, we can automatically throw these out, right? Because we see that they have a slope of 1/2. So here are your choices. You can actually just write the equation yourself at this point, and you could say, well, 1 equals -2 times -3 plus b. And then here we're going to get 6. Then we would subtract the 6, and it's going to give us a -5 equals b, which means it has to be this one. The other choice is that you can take your ordered pair and plug it in to either this equation or this one and see which one gives you that the left-hand side is equal to the right-hand side. Meaning, so for example, if I plugged it into that top equation, I would have 1 equals -2 times -3 plus 1, and I'm running an algebraic test. I'm saying, does 1 equal 6 plus 1? And 1 does not equal 6 plus 1. And so that tells me that that's not the correct equation. So then testing it in the equation that we already know works, but again, this would have been giving you a different way to solve it. We would say, okay, does 1 equal -2 times -3 minus 5? And so we would get 1 equals, and again, this is an algebraic test. We would say 6 minus 5, oh look, 1 equals 1, check, which means that letter D had to be the correct answer. So you could have done it either way. So where you just find it, or you rule out these two and then you plug it into your last two options and find out which one works. So that also works as well. All right, let's look at this last example. So it says, write the equation of a line that is parallel to the line y equals 4. Well, what I hope you remember is that the line y equals 4 graphs a horizontal line at y equals 4. So if you draw yourself like a little postage stamp graph at y equals 4, 1, 2, 3, 4. And so it's going to go across there. And it says a line that's parallel to y equals 4. Well, what's another line that's parallel to y equals 4? Y equals anything. Y equals, could be like y equals 1. Y equals 0. Y equals 1,000. Y equals anything but 4. So y equals c as long as c cannot equal 4. So it's just going to be another horizontal line. All right, how about something that's perpendicular to the line y equals 4? That means it has to be a vertical line. Well, what's the equation of a vertical line? You could do x equals 4, x equals 2, x equals -10. You could do x equals 1/2. You could do x equals anything. X equals c, where c is a part of any real number system. All right, letter C, it's parallel to this one, and it contains the point 10, 3. So it's parallel to y equals 4, which means, again, like do a little postage stamp graph. It's parallel to y equals 4, 1, 2, 3, 4. So that means we've got a horizontal line at y equals 4. And so our line is also going to be a horizontal line, is what that tells us. So it's going to be y equals something, and then it goes through the point 10, 3. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up 1, 2, 3. So if it has to go through that point and it's parallel, what's our y value going to be? Y equals what? And I'm hoping you're saying 3, right? Because if we have a horizontal line, we know it's horizontal because it's parallel, and it has to go through this point of 10, 3, then that means it has to be y equals 1, 2, 3. So it'll be y equals 3 for that one. All right, letter D. If we know that we have a perpendicular line to this, which automatically means it's going to be a vertical line, right? So if it's perpendicular to my line y equals 4, and it contains the point 10, 3, now we're talking about this situation. 10, 3 is here. And now it's a vertical line that goes through that. 100% of the time, my x's are at what value? 10. So it'll be x equals 10. All right, we've got two more similar to those. So if we have a line that's at x equals 4, 1, 2, 3, 4. So I'm going to say x equals 4. That's a vertical line. If we have a line that's going to be parallel to that and it contains the point 7, negative 2. So if it contains the point 7, negative 2, 1, 2, 3, 4, 5, 6, 7, down here at negative 2, and it's parallel, that means it's got to be a vertical line through the point of 10 or 7, negative 2. What's going to be our equation? And I'm hoping you say x equals 7, because it's going to be a vertical line straight through x equals 7. So if it's perpendicular to x equals 4, and then it contains the point 7, negative 2, that means it's got to go through that point, and I didn't draw a very straight line. But it's got to go through this point. If it's perpendicular, it's going to be a horizontal line. It's going to go through this point of y equals negative 2. And the line of y equals negative 2 is going to be this one right here, which is going to go through this point, and it's perpendicular to x equals 4. All right, that's the end of this video. Thanks for tuning in.